In this video, we're going to be looking at the special value triangles. Now, the special value triangles are really just triangles that have very specific definitions with their angle measures. So let's go ahead and start with this setup where I'm going to have a right triangle such that this angle is 90 degrees, this angle is 45 degrees, this angle is 45 degrees. That again, notice that every triangle is going to add up to 180 degrees. And I'm going to call this this side 1, this side 1. Which means that if I look at this accurately and clearly, then I have an isosceles triangle. Again, I can find this missing side by taking legs squared plus legs squared and force it to be equal to c squared. That's again this hypotenuse that I'm going to call that I'm missing. In this case, this is going to be 2 equals to c squared, and then therefore c is equal to plus or minus 2. Sorry, the square root of 2. And it's important to understand that technically this triangle length has 2 possible solutions, but the negative solution doesn't really make any sense given that, again, we don't really have negative length. So this is going to be square root of 2. Now, with this setup and this evaluated, what we're going to say is I want to know what is the value of the sine of 45 degrees. Now, again, what we're trying to do in this particular set of content is we're trying to come up with very clear values. What is the sine of 45 degrees always equal to? Doesn't matter if we're in a triangle, doesn't matter if we're just building a random angle somewhere. We're talking about what is the sine of 45 degrees? Well, the sine of 45 degrees, I'm going to go ahead and use this angle as my comparison, just because I feel more comfortable with playing with these values here as opposed to these values here up here. So in this case, the sine of 45 is going to be 1 over radical 2, because again, that value is opposite over hypotenuse. So this is not appropriate notation. We don't like having radicals in the denominator of fractions. So what we're going to do is we're going to rationalize that denominator. The way that we rationalize that denominator is to multiply top and bottom by that radical. Meaning, I'm going to go ahead and ignore that equal sign that I put in there. It's going to be the square root of 2 on top and on bottom. When I multiply the bottom by the square root of 2, I'm going to get 2. When I multiply the top by the square root of 2, I get radical 2. And therefore, the sine of 45 degrees, no matter what we're working in, will always be a comparison of radical 2 over 2. Okay, this is the value of sine of 45 degrees no matter what we do. Let's go ahead and ask the question for the cosine of 45 degrees. In this case, I'm going to do the exact same thing, but I'm going to go down here for the adjacent over 1 radical 2. So I'm going to get the exact same thing, and it's going to convert to the exact same thing. So that means that the sine of 45 degrees and the cosine of 45 degrees are actually the same value. At this point, what we're going to end up doing is we're basically going ahead and creating a table of values. Sine and cosine, then we're going to play with the tangent of 45 degrees, but instead of using 45 degrees, I'm going to use pi over 4. Because again, we don't want to forget that radian measures is still something we can work with. So 45 degrees and pi over 4 are the same values. They're just, again, different measurement tools. But tangent of 45 degrees is going to be opposite over adjacent, so that's 1 over 1, which is really just 1. And then I can go ahead and do the reciprocal values. Now, when I'm going ahead and setting up the table of values for the reciprocals, sine of 45 degrees, I'm looking at cosecant of 45 degrees, or again, pi over 4. This is going to be equal to, well, the reciprocal of radical 2 over 2. But this radical 2 over 2, I'll be honest with you, is silly for me to rewrite in its reciprocal form, which will be 2 divided by square root of 2. And that particular form right there, I'm going to have to rationalize it anyways. It seems more logical to go back to the original before I rationalized it and flip that one instead. So it's going to be radical 2 over 1, which is really just radical 2. I'm going to do the same thing for secant of pi over 4, or 45 degrees, which is going to be the same thing, square root of 2. And then when I find the cotangent of pi over 4, I actually end up getting 1 over 1 flipped is just 1. So now I know that anytime that I'm plugging in 45 degrees or pi over 4, they're the same thing, into any one of these 6 functions, any one of these trig functions, these 6 trig functions, I can find a very specific value every single time. So this is your special triangle for 45 degrees. We're also going to do one more specialized triangle that correlates with 30 and 60 degrees. You remember the ones, the 2 other, or the 3 angle measures that I had you guys forcefully memorize in the previous videos. Again, they come back more or less with a vengeance now. So this next time, I'm going to go ahead and draw another triangle here. But in this triangle, I'm going to make all the side lengths 2. I'm also going to make an equilateral triangle, which means that all angle measures here are 60, 60, and this one up here is 60. But what I'm going to do is I'm going to go ahead and cut it directly down the middle. So when I do that, I'm going to cut this angle with a perpendicular bisector, making it 30 and 30, and then this 2 changes to a 1 on this side and a 1 on this side. So there's my 90-degree angle. Now I can talk about, again, right triangle trig, where this side doesn't really matter. Again, this is the building of the specialized triangle values of 30, 60, and then again 45 up here. So for this one here, I still have to find this side length right here. And the way that I'm going to do that is I'm going to note that I have the hypotenuse this time. I have one of the side lengths, so I have 1 squared plus unknown squared equals to 2 squared. So I'm going to have 4. This is going to be 1, which I'm going to subtract over. I'm going to have b squared is equal to 4 minus 1. So b is equal to plus or minus the square root of 3. But again, one more time, the negative doesn't make any real mathematical sense in the concept of a length. So this is going to be positive square root of 3. That's that side length right there. So now we're going to build, again, one more time, another table of values. Just like we did up here with sine, cosine, tangent, secant, cosecant, and cotangent, we're going to do the same thing we did down here. But the problem with the table of values down here is I need two sets of them. I need the sine of 30 degrees. Sorry, I should probably have degree symbols in every single one of these locations here when I drew them in. I'm going to have the sine of 30 degrees. I'm going to have the cosine of 30 degrees. I'm going to have the tangent of 30 degrees. And then I'm going to have, again, all of their reciprocal functions. So the cosecant, I'm going to start doing the pi over 6s, because the pi over 6s is the same thing as 30 degrees. It's something that we should make sure that we remember. Cotangent of pi over 6. And then I have to have a whole nother set of values that I have to more or less memorize. And that's going to be the sine of 60 degrees, the cosine of 60 degrees, the tangent of 60 degrees. And again, just to keep things consistent, let's go ahead and do cosecant of pi over 3. Secant of pi over 3, because again pi over 3 is your 60 degrees, and then cotangent of pi over 3. So now when we're filling in all of these values for these tables, we have to again make sure that we understand where they're coming from. They're coming from this triangle, and what all of their values are. So the sine, let's start there. Sine of 30 is going to actually be from up here. That's where we're going to work from. And the sine is going to be opposite, so opposite of that angle measure is 1 over 2. So this is equal to 1/2. If I do the cosine of 30, I'm going to go to the adjacent side. Now this is the adjacent side. Even with me crossing out that triangle, this side here is the adjacent side to it, because this is opposite and this is hypotenuse. So I'm going to have radical 3 over 2. So this is square root of 3 over 2. Tangent is going to be opposite over adjacent. So 1 over radical 3. But if I rationalize that denominator, I'm going to get radical 3 over 3. So far, so good. If I use the reciprocal functions, this is going to be a value of 2. This is going to be a value of 2 divided by the square root of 3, but we can't leave it in that form. We've got to rationalize that denominator. So 2 square roots of 3 over 3. And then finally, when I flip this one, I'm going to go back to here and flip this one. It's just radical 3. Again, this seems like a lot of values to remember. Now, what we're going to do is we're going to have to make sure that we understand that these values all have correspondence with each other. There's a comparison with them where we can memorize a certain small set of them and then know how they compare to other values so that we don't have to memorize 6, 12, 18 different values. So for the sine of 60, again, now we're going to go to this side of the triangle right here, this angle here. I'm going to go opposite over hypotenuse, so radical 3 over 2. Notice how the sine of 60 and the cosine of 30 actually match up. You'll notice also that the cosine of 60 and the sine of 30 also match up when we go from here, adjacent over hypotenuse. The tangent now, when we look at this one, is going to be coming from here. So it's going to be opposite over hypotenuse, opposite over adjacent, so radical 3 over 1. And that's actually going to be the same as the cotangent function. And the cotangent function here is going to be simply this radical 3 over 3 again, because I'm going to flip this being radical 3 over 1. I'm going to make it 1 over radical 3 and then rationalize the denominator. And then you'll notice that these things are nothing more than flips of those ones as well. So this function right here is actually going to end up just being that this thing flipped upside down, or 2 square roots of 3 over 3. So these are all 6 of your trig functions for the main important values, 30 degrees, 45 degrees, and 90 degrees. I'm going to go ahead and add to this video the last section of content just because it's a short bit of content, and it's called the cofunctions. So in this last video, or in this last setup, we're going to talk about the sine function and how it compares to that of its cofunction. So the sine of theta, how does it compare to the cosine of theta? Well, it's not going to be the cosine of theta, but the cosine of 90 degrees minus theta. This is the rule of how your cofunctions compare. Every cofunction has this property. It means that if I were to know what the value of the sine of, let's say, 33 degrees is, then I also know what the cosine of 90 degrees minus 33 degrees is. So if I could identify this value, then I could say that the cosine of, in this case, it's not 60, but 57 degrees ends up being. If I know this value, then I also know this value by the way that the functions are defined. So again, we have the sine, cosine, and tangent functions. We have the reciprocal functions, cosecant, secant, and cotangent. But then we also can identify that the sine function is really nothing more than the cosine function is really nothing more than a shifted concept of the sine function. So this holds true for all the cofunctions, meaning the cosine function is the same thing as the sine of 90 degrees minus theta. And again, another way that we can identify this is using that pi over 2 concept. So if I talked about tangent, the tangent of theta is equal to the cotangent of pi over 2 minus theta, just like cotangent of theta is equal to the tangent of pi over 2 minus theta. And this is also holding true for the cosecant and the secant functions. So the secant of theta is equal to the cosecant function of, again, 90 degrees minus theta. And notice how I'm very careful about making sure that my degree symbols are in there for the 90s and not in there for the radian measures. And then finally, cosecant of theta is equal to secant of 90 degrees minus theta. So this is the concept of your cofunctions. Keep in mind that these are just another way to see and define those cofunctions. But again, depending on what you're asked for, you're going to have to understand how these things compare, how these things manipulate, and how these things work. In most cases, this page here is your most important page of information, knowing the 45, 45, 90 degree triangle trig values, as well as the 30, 60, 90 degree trig values. If we can identify those ones relatively smoothly, then the rest of the trig concepts come out quite easily.